Hello students, before we start our chapter, I would like to request you all to watch our introductory 2 videos given by me so that you will be clear about the 3-step strategy to do DHAMAKA in physics exams. We have given the videos in the description box, or you can just click on our videos displayed at the end of this video for either introductory 2 videos or the next videos. Okay then, let's enjoy physics by Mr. Patel, who has a long, profound experience of 29 years of teaching physics in Sainik School, Balachar.
Prism. We have seen that yesterday the prism designed to bend or deviate the light by 90 degree or 180 degree, they make a use of the total internal reflection. That is, in both the cases, the total internal reflection should take place. Suppose this already we have studied yesterday. So ray is going parallel. If you draw the normal at the surface, then this will. So this is angle 45. It is more than this IC, more greater than this I. I is greater than IC. I is greater than IC for plate and the crown glass, both the glasses also. Such a prism is also used to invert images without changing their sizes. There is no magnification, but it changes the direction. In the above two cases, the critical angle IC for the material of the prism must be less than the 45. The critical angle must be less than, the IC must be less than I. Correct? I is 45. Correct? And this is true for both crown glass, that is IC critical angle for crown glass is 41.14, and for dense flint glass 37.31. Correct? This has a refractive index more, so critical angle is less. Diamond is still less. Diamond has 24.24 degree because the refractive index is 2.42. Now, to invert an image without deviation, that is bending, the ray here it bends, but finally it goes out as a parallel. Correct? Image is inverted, but there is no bending in the finally. Correct? So this type of prism or trapezium, they are used in the periscope, binocular, projection lantern, etc. Correct? In periscope, this type of prisms are used. So what is the use of this prism? What are the advantages of using prism in this optical instrument, periscope, binocular and projection lantern instead of the mirrors and glasses? Because in case of the mirror and glasses, there is a loss of intensity of light. Here, most of the light in internal reflection, light is reflected totally, so there is no loss of intensity, about 4 to 5% loss, about 90%, 95% intensity you get. So there is a major advantage. Now sparkling or brilliancy of the diamond. Diamond is cut in such a way that the light once enter from the one face. It is because the technician, it is a skill of a diamond cutter that cuts the diamond in such a way. Naturally occurring diamond, they do not show any brilliancy, but they are to be cut. The skilled diamond cutters, they cut it, and they cut it in such a way that light once enter from the one edge side, that undergoes a multiple reflection before it emerges out from the face, and that is why it shines brilliantly. Correct? The brilliancy of diamond is due to the total internal reflection, as the refractive index of a diamond, and D for diamond, and for refractive index A for air, with respect to air, is very large, that is 2.42. Its critical angle is 24.4 degree, very less. the face of the diamond are so cut that the light entering the crystal suffers total internal reflection repeatedly, and hence gets collected inside, but it comes out through only a few faces. Hence it shines brilliantly when seen in the direction of the emerging light. Next one is the another application of internal reflection, optical fiber. It also works on the principle of, that is, phenomena of internal reflection. It works on the phenomena of total internal reflection. An optical fiber is a hair thin long strand of quality glass or quarters surrounded by glass coating. There is a glass coating. This is a core. Core has higher refractive index, and this is a cladding, that is, this is coated by this cladding, has a low refractive index. Correct. So when ray enters from the denser medium to the rarer medium, if it falls at an critical angle greater than the critical angle of this material, then it will undergo the total internal reflection. Again, this angle is greater than the critical angle, again it will be totally reflected. So there is a multiple reflection takes place before it comes out from the other end. Correct. It is used for transmitting audio and video signal. It is used to audio and video electrical signal. That is, first it is to be converted into light, because it is for the light. So any signal, electrical signal, is first converted into light, and light is transmitted. It is used for transmitting audio and video signal through long distances when a light signal is directed at one end at the suitable angle that is greater than the critical angle it should be. It undergoes the repeated total internal reflection at each stage. There is no appreciable loss in the intensity of light. About 95% intensity you will get from the other end. They are fabricated such that the light reflected at one side of inner surface strikes the other sides at an angle greater than the critical angle. Even if the fiber is bent, light can easily travel along its length, so you can bend it. Thus, an optical fiber can be used to act as an optical pipe also, because you can bend it. This pipe can be you can bend it also. Now uses. The optical fibers are used for transmitting and receiving electrical signals, which are converted to light. First it is to be converted to light, and then it is to be transmitted through the pipe or fiber by suitable transducers. They are also used as a light pipe for visual examination of internal organs. The doctors, it is used in the medicine. The doctors, they use it to examine the internal organs like epicorus, stomach, and the intestines. Correct. It is also used to decorate in the decorative lamps also. In decorative lamps, the bulb is connected in the bundle of fibers, tubes at the bottom, and the light passes from the optical fibers, that is, at the end it shines brilliantly. In silica glass fibers, it is possible to transmit more than 95% of the light over a fiber length of 1 kilometer. See, that is without loss also, 95%. In the form of photometric sensors, they are used to measuring the blood flow in the heart. Correct? That is also used in medicine. In the form of the refractometer, they are used to find the refractive index of liquids. Indices of different liquids, also indices of liquids. Refraction at spherical surfaces. These are spherical surfaces. The figure shows the formation of an image I of an object O placed on the principal axis. This is the principal axis. Correct. of a spherical surface. This is spherical surface. This is the principal axis of spherical surface with the center of curvature C and radius of curvature R. Correct? That distance from the pole to the C, or optical center to the C. Correct? The rays incident from a medium of refractive index N1. This is first medium is having the refractive index N1. The rays are incident on the spherical surface from the refractive index N1 to the another refractive index N2. This is, it refracts from this and form the image I. This is one rays, it bends towards the normal. This is a normal at the surface. Correct? Instead of going straight way, it will bend toward the normal. Correct? It won't go away from the normal because this is the denser medium. For a small aperture, Nm can be taken to be the nearly equal to the length of the perpendicular from the point N, as we have assumed previously, and on the principal axis. For a small aperture, I have shown bigger for your convenience of study. If N point is very close to the M, then this could be considered as a perpendicular drawn from the N on the principal axis, this Nm. Correct? So tan NOM is equal to Mn upon OM, and tan NCM, this angle, that is equal to Mn upon MC, or tan NIM, this angle is equal to, the front side upon this near adjacent side, that is MI. Correct? For a small angle, now in the triangle, and this could be taken as a theta, then theta is equal to theta, that is this angle we could take it. Now in triangle NOC, this I is the exterior angle. So exterior angle is equal to sum of the interior two opposite angles, that is this angle NOM and NCM, these two angles. You can write the number 1 and 2 also. Correct? So angle I is equal to NOM plus NCM, because this is an exterior angle of this triangle. Correct? So I is equal to NOM is equal to Mn upon OM. NOM is equal to Mn upon OM plus NCM, that is Mn upon MC. Similarly, R is equal to this angle plus this angle is equal to this angle. So this angle is equal to R minus this one. Correct? Exterior angle is equal to interior to sum as before. So similarly, R is equal to Mn upon MC. That is this angle. Correct? Tan theta, this N is very close to that tan theta can be taken as a theta. Correct? That is R. And minus Mn upon MC, this angle, that is equal to Mn upon Mi. This is equation 2. Now Snell's law, according to Snell's law, N1 sin I is equal to N2 sin R. Correct? You know that sin I upon sin R is equal to N21. You will get the refractive index of the second medium, that is N2 with respect to N1, that is N2 upon N1 also you can. If you do the cross multiplication, N1 sin I is equal to N2 sin R also. So N1 sin I is equal to N2 sin R. Correct? That is also you can write. So N1 into sin I, that is small theta, we can take sin theta is equal to theta. Tan theta can be taken as a theta, and theta can be sin theta can be taken as a theta. So I is equal to, as we have studied, I is equal to Mn upon OM plus Mn upon MC, and R is equal to Mn upon MC minus Mn upon Mi. Correct? N2 Mn upon MC minus Mn upon Mi. That is equal to N1 upon OM, N1 upon OM, Mn is common. Correct? Mn is common. So N1 upon OM plus n2, that is this you can take, this mn upon mi, this you can minus that you can take here, that is n2, correct, mn common, n2 upon mi, n2 upon mi, barabar, and this term n1 mn upon mc you can take this side. So n2 upon mc, correct, minus n1, and this is mc, n1 upon mc. So n2 minus n1, I will eliminate it one step, you can write n2 minus, just rearrange it and do it, correct. Now OM is minus u, OM, this is the object distance and this is the direction of the incident light ray, this remember very well, and all distance measured from the pole as a origin. So distance is measured like this, so this is minus, OM is minus, correct. So minus u, and this is object distance u, that is minus u, correct. Mi is in the direction of, that is left side of the surface, that is always positive, correct, except virtual image. Remember, if it is virtual, then it is minus. This is mi is also plus, and mc is also refractive index of this concave. If it is convex, convex, it is plus, concave, then it will be minus. We will see in the next topic, correct. So introduce this with the sign convention, that minus n1 upon u plus n2 upon v is equal to n2 minus n1 upon r. That for n2 upon v, you take this term here, and this you put as a first, that is n1 upon u is equal to n2 minus n1 upon r. This equation gives the relation between the object distance u, image distance, and the refractive index and the radius of curvature. Object distance, image distance in terms of the refractive index for the medium and the radius of curvature, all they are related. N, R, U and V, 4 are related. Now example 9.6 on page number 325. Light from a point source in air falls on a spherical glass surface, n is equal to refractive index, n is equal to 1.5, and the radius of curvature is 20 centimeter. U is 100 centimeter, correct, already given. At what position the image is formed? Now U is given, U is always negative, whether it is a lens or whether except it is a virtual image. The U is minus 100 centimeter, V is to be calculated, radius of curvature is also plus 20, correct. So we know that equation just now you have studied, n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. So n2 is refractive index is 1.5 with respect to air upon v, plus this is minus u, minus minus, plus n1 is refractive index of air is 1 upon 100, and that is equal to 1.5 n2 minus air has refractive index 1 upon r is 20. That is equal to 1.5 upon v is equal to 0.5, 1.5 minus 1, that is 0.5 upon 20 minus 1 upon 100. Simplify it, that is 1.5 upon v is equal to 5 upon 200 minus 1 upon 100, correct. This is 0.5, that is 5 upon 10, that is 5 upon 200. So LCM 200 is very simple one. So this is 5 minus 2, that is 3 upon 200. 1.5 upon v is equal to 3 upon 200. So v is equal to 200 upon 3 multiplied by 1.5, that is 3 by 2, 3 by 2, 3 cut, this is 2 cut the 100. So answer is 100 centimeters.